All right, next up is number 35, which has to do with resistance and electricity. We're given this relationship where the total resistance, the inverse of the total resistance is the sum of the inverses of the two other resistance that are hooked up in parallel to it. I highly recommend looking this up. A parallel circuit is not a really hard thing to understand, and it's kind of a cool thing to know. Anyway, so we're trying to figure out a couple things. We're going to set up our gist for this. But before I do that, I'm going to rewrite this equation because we'll use this version, but we'll also use the exponentiated version in order to do the differentiation. So I'm just going to change this to be r to the negative 1 is r sub 1 to the negative 1 plus r sub 2 to the negative 1. And let's set up our gist. Okay. So things that we're given in here are that all of the resistances are measured in ohms, and then R1 and R2 are increasing at rates of 1 and 1.5 ohms per second, respectively. So we're given that dR1 dt is equal to, it's increasing? Yes, increasing. So 1 ohm per second, and dR2 dt is increasing at 1.5 ohms per second. At what rate is R changing? So we're looking at, the thing we're solving for is dR dt, no subscript here, the total resistance. At what rate is the total resistance changing? At the instant when R1 is equal to 50 ohms, and R2 is equal to 75 ohms. Okay. Now the take that we have here, well, clearly we're going to have to use this formula. So we've got 1 over r is equal to 1 over r sub 1 plus 1 over r sub 2. And we're going to need to know what the total resistance is at this instant. So we're going to use this to solve for r at this instant. So 1 over r is going to equal 1 over 50 plus 1 over 75. And then you do a little bit of algebra, and you get that r, we'll do common denominators and all that good stuff, that r is equal to 30 ohms. Okay, so we're going to need this. We've got these. We're solving for dr over dt, and now we're going to come back to this form of our rule. So if I take the derivative with respect to time of the total resistance inverted, which is equal to the first resistance inverted plus the second resistance inverted, then this here is going to give me negative 1 r to the negative 2. There's the derivative of my outside function. But this resistance changes with time, so the derivative of the inside function would be dr over dt. That's going to equal same deal here and same deal here. So this is going to be negative 1 times r sub 1 to the negative 2 dr sub 1 over dt plus negative 1 times r sub 2 to the negative 2 dr sub 2 dt. At this point, we have a value for r, we have a value for r sub 1, we have a value for r sub 2. We also have values for how R sub 1 is changing at that moment and how R sub 2 is changing at that moment. So at this point, it's just a substitution. Plug in, and the thing that we're looking for is that amount. It looks ugly, but it's really not. Because once you know how to do this, it's the same exact thing for all of them. Another thing to notice is that you've got a negative is equal to a negative plus a negative. You could just drop all the negatives because your resistance is going to end up to be positive, and you know that your total resistance should be increasing since these are both increasing. And since this is an additive relationship, if this rate is increasing, then this rate should be increasing as well.